These are the section 2.4 notes, complex numbers. This is page 1. So up at the top, we are going to review finding the square roots of numbers. Remember that the square root is the number that you can multiply by itself to get another number. So here, 49, we can write as 7 times 7. So the square root of 49 is 7. Notice that once we take that square root, we use up that radical sign. It does not follow down to the 7. B looks a little more involved. Again, I am going to write it in pieces, prime factors. 5 times 5 times A times A, B, 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 6 B's. Okay. Square root is going to be anything that happens twice. So I get a 5. I've got A times A. And then I'm going to look at the B's. I've got 3 B's here and 3 B's here. I get B to the 3rd. 5 times A times B to the 3rd. Remember that that radical is also that power of 1/2. So we could have looked at this as 25a squared b to the 6 to the 1/2 power, and then applied that 1/2 power to everything inside. So C. Let's see how I can break this down into perfect squares. 72 is 36 times 2. A squared's already a perfect square. I got b squared times an extra b. I am going to pull out the perfect square parts. Square root of 36 is 6. Square root of a squared is a. Square root of b squared is b. And then I'm going to leave this 2b under the radical, because those are not perfect squares and cannot get pulled out. There are times when we will have something under the radical that we cannot get a real solution for. You've been told over and over and over that you cannot take the square root of a negative number. Sometimes we need to be able to work with those square roots of negative numbers and get to a point where we get a real solution. So we have got a number I defined such that I is the square root of -1, which means if I square both sides, I will get I squared equals -1. And these are the two most useful ways to work with i's and the radicals of -1. So I can factor what I have underneath here. I've got 7 times -1. Cannot simplify the square root of 7, but the square root of -1 is I. Sometimes we move that out front, in front of the radical. You want to be very careful that it does not look like that I is living under that radical sign. B, I am going to look at this as the square root of 16 times -1. Square root of 16 is 4. Square root of -1 is I. See, I've got the negative square root of -13, and we are so used to two negatives undoing each other that we kind of intuitively want to do that here. And we are going to stop ourselves and remember that what we have outside a radical and what we have underneath are two different numbers, and so that negative does not carry through. I'm going to keep the negative outside. We're going to take the square root of the negative inside and make that an I. So on D, same thing. I got negative. This time I got the square root of -64. Square root of 64 is 8. Square root of the -1 part is I. And on D, I'm going to factor this a little more. 14 is 16 times 3. 48 is 16 times 3. Holy moly. Times -1 gives us that -48. I get 4 square roots of 3 times I. Again, I out at the end. So we have now the opportunity to talk about what a complex number is. A complex number is always of the form a plus bi. Notice both a and b are real numbers. Okay. A is said to be the real part, and b is said to be the imaginary part. Keep in mind, we know it's the imaginary part because it is being multiplied by I. So our imaginary numbers are going to look like this, a plus bi, where a is not equal to 0, b is not equal to 0. We're going to get things that look like 3 plus 4i, 5 minus I. We can also have pure imaginary numbers, and that is defined as a plus bi, where a is 0. That just means there's no real part. And so we get bi only, 7i, negative I, 143i, whatever we are working with. Those are pure imaginary numbers. And then we also have real numbers of the form a plus bi, this time where b is 0. And so this is just a, and these are real numbers the way you're used to seeing real numbers. 13, 1, negative 4, all of these are purely real.